Hello, my name is Francis and I'm a master's student in electrical engineering and computer science at MIT. Today I'm going to show you my project Varick, a modern language for RTL design and verification. My inspiration for this project comes from my experience as an intern working on ASIC design and verification in industry. Silicon engineering is at the cutting edge of technology, and yet the software stack that is used feels like it's stuck in the 90s. System Verilog is an archaic language, and any IDE support that exists is so slow and clunky that in practice many engineers prefer to write code in command line editors like Vim or Emacs. On the other hand, if we look at the software world, we see that software development practices have raced ahead. A combination of high productivity languages coupled with high performance IDEs with intelligent code assistants have led to tremendous progress in programmer productivity. This has led to a new generation of programmers that rely on the modern software stack to write and maintain large and complex code bases. In comparison, the hardware ecosystem is miles and miles behind. What is needed is a language that bridges modern software development practices with the particular needs of hardware design and verification. This is the problem that Varick aims to solve. Varick is a hardware description language that aims to be a drop-in replacement for System Verilog. It leverages the productivity gains of the modern software stack to reduce development time and cut down on engineering costs. Varick builds upon Kotlin, a modern general-purpose programming language with a clean and expressive syntax, a vibrant ecosystem, and support from state-of-the-art IDEs. Varick is Kotlin, reinterpreted of the semantics of a hardware description language. Varick code is not run as Kotlin. Instead, it is translated to System Verilog by the Varick compiler. This translation process is direct, typically one-to-one correspondence between the input and output source files. Varick generates readable System Verilog, similar to what an engineer would have written. Let us take a look at how it all fits together. On the left, we have the Kotlin environment, and on the right, we have the System Verilog environment. The Kotlin environment is optimized for programmer productivity. The System Verilog environment has mature tool flows for simulation and logical synthesis. Varick is the bridge between the two. Going towards the right, the Varick compiler translates Kotlin source code into System Verilog. However, we can also go in the other direction. If we had System Verilog source code that we would like to reference from the Kotlin environment, the Varick importer can be used to import the declaration headers. This allows us to make use of System Verilog libraries, such as the UVM, directly in Varick. It also enables us to benefit from the productivity improvements of Varick without having to rewrite any legacy code. Let's see it in action. This is the IntelliJ IDEA IDE. It is the flagship product of JetBrains and it's what all the cool kids are using these days. Pretty much every CS major graduating from college right now has used IntelliJ IDEA or a similar JetBrains IDE. Varick works with IntelliJ IDEA out of the box. Here we have the build script for our Varick project. We can see that it depends on the shared library project and it imports from the UVM. The Varick toolchain is integrated into the IDE. We can invoke the importer directly from the side panel. This generates the declaration headers that we can reference from the Kotlin environment. So let's create a class. We'll call it agent and it'll extend from UVM agent. So it's going to have a name, which is a string, and a parent that's a UVM component. And we're going to have it extend UVM agent. And you can see that the relevant imports were automatically added. All right, let's get rid of this guy. We can run the compiler in a similar manner. So let's open up the top level module of this test bench. And you can see that here we instantiate the device under test. So if we look in the build directory, we'll see what it turned into. And let's place these guys side by side. So you can see that the declarations annotated with make have turned into module instantiations. In general, Varick implements HDL semantics of annotations, base classes, and library functions. The original line numbers are indicated in these brackets. So you can see that class.dot was originally declared on line 20, and here it is on line 20. This makes it easy to go back and forth between the original and the generated source code. Varick improves upon System Verilog in a number of ways, but I'll boil it down to just two things: the language and the environment. We'll start with the language. The Varick language provides better type safety and has a simpler and easier to work with syntax. To get a sense of this, let's take a look at the keywords defined in each language. Kotlin has 27 hard keywords. These are the keywords that cannot be used as identifiers. System Verilog, on the other hand, has 248. System Verilog draws from a mishmash of languages such as Verilog, OpenVera, and E. This makes it an unusually difficult language to work with a very steep learning curve. Kotlin, on the other hand, is easy to learn and easy to use. Anyone with experience with Java or C++ can probably pick up the main features of Kotlin in a day. Let us now turn to the environment. An essential strength of Varick is that it enables the modern IDE workflow. Excellent code assistance tools provide informative error and warning messages as the code is written. The intelligent autocompletion is fast, accurate, and type-aware. Package dependencies are automatically managed by the environment, with necessary imports automatically added and unused imports automatically removed. Documentation command blocks similar to docstrings in Python or javadocs in Java can be used to document source code. This documentation is at the fingertips of the programmer. They do not need to leaf through a 1,000-page language reference manual. Varick enables all of the bells and whistles of a modern IDE. Varick bridges the technology gap between hardware design and verification and the vibrant software community. Programmers graduating from college these days expect sleek and powerful IDEs. Varick delivers this by leveraging the tools built for the Kotlin ecosystem. Its modern syntax and environment will lead to shorter schedules, faster onboarding, and reduce engineering costs for hardware design and verification. Varick is an open source project under the Apache 2.0 license. For documentation, examples, and setup instructions, check out the website linked below. I am actively looking for feedback and collaborators, so if you have any questions or comments, please reach out to me. I'll be happy to talk to you.